Hi guys, this is the second part in a video trying to solve the following question. A uniform ladder rests against a smooth wall as shown in the diagram below. If the ladder weighs 200 newtons, the ground has a coefficient of friction of 0.4 newtons, and a person weighing 800 newtons starts to climb up the ladder. Determine how far up the ladder they may go before the ladder starts to slip. In the previous video, we drew a free body diagram, and from that free body diagram we determined the equations of equilibrium for that system. So we had three equations of equilibrium for the forces in the x direction, the forces in the y direction, and the moments around a single point G. We also knew that in this system the amount of friction seen is proportional to the normal force, because we're looking at the maximum case where there is a maximum amount of friction being provided by the ground. We then tried to solve the system of equations by substituting and using simultaneous equations methods, and we have come to a point where we've calculated the value of x, the distance along the ladder in the x direction here that the person has moved this way. So next step here is we can place our values here for how far the value of x is away from the left hand side into a calculator. So here we go, 200 times 2.6 minus 400 times 9 divided by negative 800, and we get 3.85. So this is 3.85 meters in the x direction. Now the next thing we need to do is find out how far along the ladder this person has moved up the ladder. So we know this distance, now we need to know the distance going along that way. What would be useful is if we knew this angle here. Now we can calculate that angle because we've got this dimension of 5.2 and a dimension of 9 meters going towards the right. So the angle theta there would be equal to, so we have tan theta equal to the opposite side, 9 meters, divided by the adjacent side, which is 5.2, and we get theta equal to the inverse tan of 9 divided by 5.2. Theta we can calculate by placing into a calculator. So here we get inverse tan of 9 divided by 5.2, and we get 59.98 degrees, close enough to 60 degrees. Alright, so now we can draw a triangle of what's going on in this position here. So here we have along in the x direction some value x, which we calculated in the previous part. So x was equal to, for this part here, which matches up with this part of our free body diagram, was equal to 3.85 meters. The angle here was theta, which we calculated previously, which is equal to 60 degrees. So now we can calculate the length of this side, which is how far up the ladder the person has climbed. So here we've got the adjacent side and the hypotenuse. We can write down a relationship here, which we'll write down at the bottom here. Okay, so now we can write down the following relationship. The cosine of the angle theta, which was 60 degrees, is equal to the adjacent side, which is 3.85 meters, divided by the distance along that ladder which that person has climbed up. We can now write down x prime, so this is equal to 3.85 divided by the cosine of the angle, which is 59.98, and then plug these values into a calculator. So here we've got 3.85 divided by cosine of that answer we had previously, and we get 7.696 meters. So the person that climbs up this ladder If he goes any further than 7.69 meters up the ladder will begin to slide. Alright, thank you for watching. Hopefully that's been useful. Leave any questions in the comments below, and thank you for listening. See you.